Good morning, good afternoon, and good evening. My name is Miriam Tuerk. I am co-founder and CEO of Clear Blue Technologies, and I'm reaching you today from wonderful Barcelona, Spain, where I'm at the Mobile World Congress telecommunications show. Telecommunications is one of our big customer areas. I will tell you that it was plus 16 and sunny today. I am joined today by Jeffrey Adams, our VP of Sales for North America, Peter Mikas, our lighting product engineer, product manager, and sales support engineer, and Jeffrey Vanderveen, who is running our marketing activities in the company. So that's our North American sales team. I've given a number of presentations for lighting in North America. As you know, it was the first sector in business that we started in. It's been a wonderful part of our business, and we continue to be very committed to it. But I've never done a sports lighting presentation before. And the reason is that, for those of you who know us, we manage and operate our customer systems for them. Everybody can see how they've been performing. People can see when they don't work. And so I kind of call it the getting naked aspect of what we do. And we've never done sports lighting before because the dog didn't really hunt. We were not yet comfortable that it had gotten to the level that it was performing. We are now very comfortable that sports lighting is a fantastic opportunity for smart power and solar off-grid. And so we wanted to walk you through a presentation around it today. And we've done a lot of detailed engineering analysis, and we are comfortable that anywhere in North America, we can now reliably deliver solar lighting, which some of you may know is a very high-powered system for any sports applications. So for those of you who don't know us, I'm going to give you a little bit of an introduction into Clear Blue and what we're all about, what some of the challenges are with traditional sports lighting, talk to you about the solution and offering that we can bring to the table, spend a bit of time on solar versus grid, give you some system examples, talk to you a little bit about what is energy as a service. A lot of people will say to me, well, isn't that just a warranty? And I'll walk a little bit through what's the difference between energy as a service and warranty, how to leverage our remote management and support, and then hopefully any questions you may have. We have a full team here ready to go. So just a little bit of background on Clear Blue. So we're all about smart power and making power systems, especially solar or hybrid systems, reliable, something that can be used for mission critical infrastructure. Now, I don't think there's a person in the world who would ever expect Duke Energy, who is the power utility for Southeast United States, to run their entire electricity grid without the ability to manage and control it. And interestingly enough, a solar powered small system is a mini electricity grid. So we started our company with a fundamental belief that if you want it to be reliable, and it's powering security cameras for forest fire detection, it's powering telecom infrastructure, it's powering smart city and solar street lights so that, you know, people don't get mugged and car accidents don't happen, then it has to be reliable and it has to work. So it's got to be as reliable as the grid. The only way to do that is to have smart power systems. So we started off with making the actual brains of an off-grid power system. So in the middle of solar panels and batteries and lights and those things, you've got to have the brains of that system. And we have developed and manufactured our own power electronics that has the smarts embedded in it. It has edge computing inside of it, as well as special power circuitry. Then you put that and connect that to our cloud. And within our cloud, we have big data, predictive analytics, energy forecasting. So we know, for example, that pretty much anywhere in the United States, the worst time of the year for solar lighting is from American Thanksgiving till Christmas, because those are the longest, darkest, cloudiest days. And if you're from Minnesota, northern Saskatchewan, you know that January, even when it can be minus 20, bright sunny sky. And so it actually works pretty good. So we have the cloud service. And then the last piece always is the people with the expertise. So if you have all this data and you look at it, it's useless unless you have the experience in the background to actually operate it. So every system we sell, we manage it and operate on behalf of our customers on an ongoing basis to bring the human expertise and to make sure things work. Some customers want to manage it themselves, or they have a service provider like a utility does. And if that's the case, then they use our tools and we do the second level management, just a second set of eyes, or we provide that as a service. We have been running smart solar power systems since the first installation that we did, even before we formed the company, which was in Tuscaloosa, Alabama, for a Mercedes-Benz factory. We installed our first solar street lights, and every one of those systems continues to operate and connect. Today, we manage and operate more than 14,000 systems in 55 countries around the world. So we're in more than 30 states. We're in 9 provinces. I think PEI is the only one we don't do. And we've processed more than 1 trillion cloud transactions of data, 15 million operating days of data. So we know what happens when you're actually dealing with the system in the field, not just in the lab. So what is it that we focus on? Well, our brand promise, the thing that keeps us, runs our ticker and keeps us excited, is to make sure those systems deliver the maximum uptime and performance that you need from a day-to-day perspective, that the lights are on and that the telecom towers are powered. And then at the same time that they run for the longest life. When you build infrastructure, you want infrastructure to last for 10, 20 years. Our systems are built to last 20 years. And then, of course, you've got the human error. You got to make it easy to install and maintain, and something that can be put together and installed on an easy basis. How we do that is 2 key things. The first is we have a patent around energy forecasting and management. Think of an electric car. You're driving a Toyota Prius or I can't remember the GM brand that they have, but you're driving an electric vehicle. You get in the car in the morning. You go from point A to point B. And the reason why people do that today is because they don't run out of gas. They know it's reliable and they'll make it. So how to manage the energy, forecast the energy is a key criteria. The sun's not shining today. We still have to make sure the system is powered and lighting. And then obviously remote troubleshooting and remediation tools. I kind of like to describe a street light, a solar powered street light, as you're driving down the highway with the car. And, if you're not steering the car, it'll slowly go off into the ditch. And without remote management and control of a solar powered street light, the thing will drive along for a while, but after a while, it'll start to, go down into a ditch. So with all of that together, you're eliminating a significant amount of maintenance visits, management, operations, figuring out how things work, replacing batteries, all of that stuff, such that you have systems that run on a reliable basis on an ongoing basis. So now let's talk a little bit about sports lighting. And the other thing I think that is really interesting about today, we've started to see a lot of projects with power utilities and ministries of transportation. If you go back about 4 or 5 years ago, we were doing a park project or a parking lot with someone who wanted to go green. Now we're doing interstate highway in Nevada. We're doing Sask Power. We're doing New York Department of Transportation. We're doing Pennsylvania Turnpike. We're doing those kinds of mission critical infrastructure. And the reason why we're doing it is because solar power has become good enough to be able to do that. So it's also hit grid parity. So when you're doing a grid project, you have much higher costs because you've got the trenching and the cabling and all of the distribution. When you look at electricity, 40% of your cost is generating the energy, on a solar panel in the middle of a field. 60% of your cost is getting the energy from that solar panel through a transmission distribution system to the actual light. So grid lighting is now more expensive because you need the cabling, the permits, the trenching, the meters, the connection boxes, etc. It also disrupts installation. You got to tear things up. You've got to deal with that. And then you've got the ongoing bills from an electricity perspective, and as well as a lot of utilities are putting surcharges on top of that. Solar power, on the other side, historically, has not always made the cut. And as I said before, on solar lighting, up until now, it didn't provide enough power. And you needed more power than what you could put on a light on a system. And if you did do it, you could have unreliable battery. The system, it's kind of like your car. You're driving along and the battery dies. You know that if your battery dies once, it just never comes back the same way. So if you have a solar power system that keeps running out of battery and it hits what we call LVD over and over again, after a few months, that battery's shot and you've got nothing working. And in order to make sure that everything's working good, it didn't have any remote management. So traditional sports lighting can be too costly and disruptive. And up until today, current solar solutions lacked enough power and control for reliable use. And I think the third thing that now that I'm talking about this, that I would like to talk about is, of course, we've had the ever increased performance of the lights. So, when I first started to do lighting, I can remember LED lights, we were, wow, we're at 80 lumens per watt. Today, we're at 170 lumens per watt. So because you're getting so much better performance from the LED lights, obviously you can do it with much less power. Instead of a 1,000-watt light, you can start looking at, say, a 350-watt light. So when you put that all together, our engineers have gotten to the point where we're ready to sign off. Peter, IES standards, is it meeting what's required? Can we do the spec? John, on the power side, will it be up, or the battery's going to die, et cetera, et cetera. You put all of that together, and we now have a solution that works for sports lighting. You don't need cabling and trenching. You can do a retrofit. You don't have to get connected to the grid. You don't have to have all that cable and distribution. You can just plunk down a pole, put a couple of solar panels on the top of it, and away you go. You can keep that existing infrastructure without ripping it up, especially if you've got parks and all the landscaping around the tennis courts or whatever there might be. You can retrofit to your existing poles, or you can use locally sourced poles, so we'll provide it to you as a power pack. And then, of course, as with every system, we will proactively manage and control it on an ongoing basis. So solar lighting has reached and is exceeding grid from a cost parity perspective. It's less trouble from a project management perspective. It's a day to install one of these poles, and it's just a local, within a square yard of area, you're digging a little concrete foundation, and away you go. You don't have any trenching. Sorry, I don't know what happened there. That was my fault. Your grid connectivity issues, needing to have distribution panels and breakers and meters to connect to the grid. All of that gets eliminated, and so your average install time is very short. And of course, you're reducing your carbon footprint. I would also add, you've got resiliency. Everything else could get cut because of power cuts, but those lights are still on because they're independent. So now let's look at the energy needs that you have and a typical lighting layout. And if you want to do some sample project analysis of a typical lighting layout to make sure that it meets the IES standards, I would encourage you to reach out to our team. Peter will work with you. But with the Cooper high-powered lights today, or an equivalent, you need a single 370 to 450 watt light, or 280 to 250 watt lights per pole in order to get the right coverage. In fact, when you look at a tennis court, you need 2 poles for each tennis court, 1 on each side, and that will actually meet the required energy levels. And as you may know, we have a partnership with Cooper, so we're working a lot with their lights. We've tested them, we like them a lot, we recommend them, but we work with any light. So if you've standardized or have a partnership with another vendor, we can provide you just with the power pack. We'll work with any light, or we can also provide you with a lighting solution. So now let's talk about the energy analysis. And this was an area of key focus from our perspective. Well, the interesting thing is that when you're in the South, like in Dallas, Texas, you've got more solar energy, but you're going to run it 12 months of the year. You're going to go play tennis in Dallas, maybe in November, December, January. If you're in northern Pennsylvania, however, you're not going to be out playing tennis in December, January, unless it's a really weird year. And so you're really looking at seasonal operations. You're looking at, March to October, early November. And so when you take those things into consideration, where you end up with is basically two of our solar panels, and we use standard in the market available panels, but at a certain spec and configuration of that panel, combined with lithium batteries, which is now what we sell from a standard perspective. A 2 solar panel, 1 battery power pack will provide you with the full lighting that you would need to be able to run sports lighting installation anywhere in North America. So in North America, we provide our energy as a service offering. And the way we provide this, because the tender will come out from a contractor, is the first 3 years of the service is included in our upfront cost. And only if the customer likes us and likes the service will they renew after 4 years. If they don't want to renew after 4 years, away they go and they just have their system. Most customers do renew with us because they see the benefit. But a lot of people ask, well, what's the difference between energy as a service versus a warranty? And I'll use a car as an example. So in a car, you have a warranty, right? And for the first 2 years, maybe even they do the oil change, but they'll change the filters, but you have a warranty for the car. And if there's some major, recall that comes, I got a recall about a month ago on an airbag, then it's covered by warranty and I can take it back to be fixed. But you still need to buy brakes and replace tires and get a new muffler when it wears out. So it doesn't mean you don't have any normal operating services. What energy as a service is that those normal operating aspects of that system are covered by our fee. So you buy the system up front, you're covered for the first 3 years. After 3 years, hopefully you renew, you pay us a small annual fee over 10, 15, 20 years. And when the battery dies, which it will eventually, because batteries are a consumable, right? They have a certain amount of energy and the energy goes down and eventually the battery's got nothing left. So you have to replace the battery. Now, lithium batteries last much longer than lead acid, but you still have to replace the battery. So the battery has at end of life. Part of the electronics, the controller, it's a mini computer. It's got MOSFETs and computer chips and things like that. So it's going to have to get replaced at some point. All of those things get replaced as energy as a service. It's not a warranty issue. Oh, there was a manufacturer's defect. No, it's just year 7 and something happened because the controller died or the battery's at end of life. All of those replacement services are included in the energy as a service. So unless it gets hit by a car or a tornado comes through or something that is not to be expected, you pay that annual fee and you never have to pay for any sort of OpEx capabilities. That's what energy as a service is. So we deliver the service to you as an energy on an ongoing basis. Part of that is we provide our cloud management service fee. We do it on an ongoing basis, and you don't have any surprises from an ongoing maintenance perspective. The secret behind all of how we do that is, again, I call it the getting naked aspect. We have thousands of systems. We've run them now for more than 10 years. We know what works, what doesn't work, when they die, when they don't die, how bad the weather is. We have all of that history, and we use that to manage and operate the systems. And so because we can remote manage, when we have an extreme weather event and there hasn't been sun for 2 months, or it's really cold or really, really hot, it's really, really hot in Texas and, the heat's killing everything. We are able to manage our systems and adjust for temperature, how that system manages. So it can go manage through high temperature situations. It can manage through extreme cold, or, one of the panels is broken and it's not getting enough energy. We make sure it doesn't kill the battery, that kind of thing. And we do that through our Illumience mission control. As I've said, I think already, we work with any street light. We'll work with third-party street lights. Of course, you may know about our Senti light or a Cooper sports lighting capability. Any of those work with our smart power. Remember, I talked about this little box in the middle that is the brains of every system. And because we work with any street light, you know, you can go retrofit, you can use existing poles, you can get with a local pole. We tried to make it as easy as possible for you to do the project anyway, anyhow. And so to put all of that together, we think it's time to start looking at solar for your sports lighting applications. It's the lowest cost, it's lower cost than the grid, it's reliable, and it's managed by us for you. And it's simple and easy. You just buy the system, you get it installed, no trenching, no cabling, and we're operating it on an ongoing basis for you. So that's our presentation for today. I'm going to open it up to questions. Are there any questions that we want to, I think you should be posting the questions in the chat if you want to. And if we don't take any questions today, you can, of course, email myself or Jeffrey or Peter anytime to ask any questions that you might have, or ask us to do some sample proposal and pricing for you if you have a project you'd like to consider. Jonathan, Jeffrey, do we have any questions from anyone?
Perfect. Yeah, I'm not seeing anything yet in the messages. Keep it open. Oh, there we go. Okay, so we have a question from West K. Are there any examples in the northern areas, excuse me, so like southern Ontario, for example?
So we've not done any solar lighting, sports lighting. This is our launch of our sports lighting product line, but we have systems in Timmins, Manitoulin, Sudbury, Windsor, Hamilton, Toronto, Ottawa, Labrador. We have systems in Euclid, Ohio, on the coast of the Lake Michigan, and sometimes Ohio is a lot harder to do than Ontario because of lake effect. So you put all of that together, we've got all the data from millions of days of operating to know the performance of a solar panel, know the performance of batteries, et cetera, to be able to stand behind the solution, because it's the same basic technology, just a bit different config.
Awesome. Okay, so we have another question too from Jason. He's asking, what would the expected pole height requirements be? Or do we have any ideas about that?
Peter, would you like to answer that question?
Yes, absolutely. So great question. Based on the basic calculations for proper light levels, we're looking at our standard 28-foot pole with 26 feet mounting height for the luminaires, with a proper angle, of course. So yeah, your typical standard pole that we have actually, that we provide all the time. So there's nothing special, no special designs. This is a very standard system.
Awesome.
And I see I'd like to add for Wes's comment regarding for in Hamilton that you've already used the technology. So kind of just building off of what Miriam was saying, while this is us launching the solar technology, the technology it's based off on is tried and true. So what has changed is we now have fixtures, sports lighting fixtures, that we're able to get more lumens per watt than that was possible previously. So we now have a light fixture that is able to allow us to provide those sports lighting levels. Yeah. So just want to make that clear. It is really in now the advancement of right here, the fixtures that are available that allow us to do this.
Yeah, so the smart off-grid controller that is at the heart of almost all of our projects. We've got 4 products now, but this is still our kind of a major part of what we do. This controller, this is a 3rd generation product, and the efficiencies and the performance, but we've shipped thousands of these. The solar panel, it's kind of like the lights, right? So you had 170 lumens, then you had 160, and before that you had 150, 140. So the lumens per watt improved performance of the lights have been going up a little bit each at the time. Same thing with solar panels, efficiency and wattage. We're now doing 440 watt solar panels with higher efficiency, higher voltage, higher current. So you add those two things together. And then the last part is we've now moved to lithium batteries. And lithium batteries, about 3 years ago, my co-founder, who's the power guy, would talk about, lithium's the wild, wild west. We have thousands of them installed around the world. We're very comfortable. We've designed our own battery management system for them. And because they are about a third the size of a lead acid battery and a third the cost of a lead acid battery, the dog hunts. So, I would have a few years ago been talking to you about 4, 8, 12, batteries from a lead acid perspective. Could have done it. Doesn't look so nice. But now we're in a level where this will work. So it's a combination of all of those things coming together, and us crossing over the line of, are we there yet? And we've looked at sports lighting many years, and now we're there. We're comfortable that we've got the solution that will meet the requirement.
Awesome. Thank you. Yeah. Does anybody else have any last questions? Speaker.
Okay.
Oh,
as I want to say,
Oh,
go ahead.
Yeah, so we got one from Ron here. So what level of play for tennis court lighting? So like recreational, club, or professional? I'm not sure if the requirement is different for.
Yeah. Peter can discuss that a little bit more, but I believe it's at recreational at 30, approximately 30-foot candle levels.
That is correct. Yes. So there are 4 levels of outdoor tennis plays, and the lowest one, which we are adhering to, because over 90% it's nothing but a leisure play, sits at about 30-foot candles with certain uniformities, of course, and we meet all of those actually.
Yeah, I would say you could always go with a third, additional pole for the area. But with these 2 solar panels and 1 battery, it's very easy for us to go 3 solar panels, 2 batteries. So if there was a higher requirement, that's more than doable here.
Awesome. Thank you for the questions, everybody. These are great. We'll give maybe 5 more seconds and then see what we have.
Okay, well, while we're waiting for that, just to re-summarize, Jeffrey Adams is our VP of Sales for all of North American lighting. Peter Mikas is our lighting specialist. He sometimes feels a little alone in the company because he's the lighting guy, but we really felt as our business has grown that we bring lighting expertise to the table, and he's been a huge asset for us and lobbies heavily to make sure that we meet the standards. And Jeffrey Vanderveen is our responsibility for marketing and supports the team. I'm Miriam Tuerk, co-founder and CEO. I've talked to many of you in the past, and we love you as customers and hope we can do more projects together. Thanks very much for joining today.
Sweet. So sorry, Miriam, we got one more question that came in here from Glenn. He's saying, how does the system perform at 55-degree temps?
So 55 Celsius.
Celsius, yes.
Yeah, so you won't get 55 Celsius in northern Canada. You might get it in Texas, but when you look at batteries and the operating temperature of a system, it takes a 24-hour average. I have lots of systems in Saudi Arabia and in Africa, northern Africa, which are very high temperature, and they take the 24-hour average. So if it hits 55 during the day, but it goes down to 30 at night, then your average will be around 40, which is just fine. So we do operate in that range. Lithium can handle it much better than lead acid. I think the last thing I would comment is we generally try to put the lithium battery either up underneath the solar panel, so it's in the shade, or we'll put a sun shield on the box. So if we were doing a project in Texas where we were going to have high temperatures, we'd either have a sun shield on the box, or it would be up under the panel where there's shading. And as you would know, that 55 will then become 40. So high temperatures is something we're very familiar with the markets we're in. Okay, any other questions or requests, please don't hesitate to email the team. We're hoping to do more webinars later this year. And in the meantime, please head out to, don't feel free to reach out to the team. And we hope we can do some projects for you.